We'll now look at what's called the second derivative. The only thing the second derivative is it's the derivative of the derivative. So we denote our functions by f of x. The derivative was f prime of x, and the second derivative is f double prime of x. And there's nothing stopping me from keeping going. I can do a third derivative, taking a derivative a third time, or a fourth derivative, and you can do these as high as you need to. However, for now, we'll strictly look at second derivatives. Let's consider this function. The first step in taking a second derivative is to take the first derivative, bring the exponent down, and subtract 1. Same thing here. When we bring the exponent down, 1/3 times 3 is 1, and then we subtract 1 from the exponent. The exponent here is 1, so we bring it down, and subtracting 1 from the exponent gets rid of the x. We now want to take the second derivative. So we bring the exponent of 3 down. 3 times 8 is 24, and then we subtract 1. We bring the 2 down and subtract 1, and the derivative of a constant is just 0. So now I have my second derivative. Now let's look at this one. If I take the first derivative, we know that we bring the number 3 down, and then this is e to the 3x. For the second derivative then, I would bring the 3 back down. 3 times 3 is 9, e to the 3x. What if we do something similar, like e to the minus x? The first derivative, I bring the minus down, times e to the minus x. And then for the second derivative, I would bring another negative sign down, so now I'm positive, e to the negative x. Now let's consider sine and cosine. If I take the derivative of sine, we know that it is cosine. And we know that the derivative of cosine is negative sine. So now I have my second derivative. Let's go ahead and continue and do a third derivative here. The derivative of sine is cosine, and then I have this negative sign out front, so negative cosine. And then if I do a fourth derivative, and so we don't have too many primes up front, we'll often put an exponent written in parentheses to indicate a higher derivative, like the fourth derivative in this case. The derivative of cosine is negative sine, and then I still have this additional negative sign in front, so now I'm at sine. And you'll notice we will circle back if we wanted to do the fifth or sixth derivatives. For cosine, we know that the derivative of cosine is negative sine. We just discussed how the derivative of negative sine was negative cosine, and how the derivative of negative cosine is sine. And then if we wanted to do the fourth derivative here, the derivative of sine is cosine. So once again, we're back up to the front. So sine and cosine do actually loop around in groups of 4. One other thing I'll discuss about these second derivatives is what's known as concavity. Concavity is kind of telling you if things open up or open down. And when we dealt with the first derivative, we talked about a positive first derivative meant increasing and a negative first derivative meant decreasing. And your second derivatives can tell you about concavity. So if your second derivative is positive, you're said to be concave up. Concave up means you open up, and it could look like any one of these pieces. And if your second derivative is negative, you're concave down. So now we look at any one of these pieces. And how exactly can we remember this? Especially with concave up and concave down. Well, there is one kind of fun way to remember it. Concave up, your second derivative has to be positive, and it looks like this. For concave down, your second derivative needs to be negative, and it looks like this. So you can think of it as a happy face or a sad face. So let's consider x cubed. We know that the first derivative would bring the exponent down and subtract 1. The second derivative, we would once again bring this new exponent down and subtract 1. If we set it equal to 0, we see that our critical point is once again 0. So what exactly happens before and after? Well, if I take a number like 1 in my second derivative, I would have 6 times 1, which is positive. A number like -1, 6 times -1, which would be negative. So from negative infinity to 0, we are concave down. And from 0 to infinity, we are concave up. We discussed in the last video about how this function was always increasing. And we can see that down looks like this, and up looks like this, and now we do look like our cubic function. So it can actually tell us a lot. And we're just going to touch on this now. In a later video, we'll really stress more about concave up and concave down, as well as increasing and decreasing.